Hello, in this video, I'll be discussing what a circuit is and some aspects to a very basic. As usual, I'll also be showing some examples of simple circuits on every circuit and Falstad Circuit Simulator. So the question is, what is a circuit? What does it actually mean? Well, the term circuit entered the English language sometime around the 14th century, and it basically just comes from the Latin phrase to go around. It wasn't for a few more centuries, the mid 18th exact, where the term was actually first used to describe a pathway for electrical current to flow. This is about the same time that the Leyden jars were invented. The usage of this term came about because scientists at the time discovered that electricity actually needed a complete or circular path flow. You can sort of think of a complete circuit as a hill or a ramp. The power source is basically the top of that hill, the ground is the bottom. Without having those two things, nothing can roll down the hill. But we generally require at least one component within a circuit that isn't the power source or the ground, as a pathway from basically power to ground creates a short circuit. Question is, why is this bad? Well, electricity itself dissipates as heat, and it will quickly heat up not just the wire, but the power source as well. Now, extremely brief contact, especially if it's with a lower power source like a single battery, is probably not going to do much. It might heat up, but you're fine. However, anything more than that, and the heat will can melt the battery. It can trip circuit breakers, fuses in a larger power source. And even just a single small battery overheating and melting, it could explode. There's plenty of toxic chemicals in there. So even that could cause burns or other damage. And with a larger power source like the AC running through your home, not only could things melt, explode, it can result electrocution, severe burns, or even death in some cases. So keep in mind that all electric components they have some kind of ratings. Usually, there's a set for maximum, there's a set for recommended because they need to give a little clearance for when there's power surges and things like that. Probably at the very least, it'll include ratings for voltage, current, temperature, a lot of other things too, depending on it. Example might be an LED. Probably dealt at this point, you probably dealt with them just constantly. They're everywhere now. Specific models are going to have specific ratings, but it's safe to assume that LED can take 2 volts and 15 to 20 milliamps, and that should be well sufficient to light it and to safely operate it. But then again, you'll always want to consult whatever data sheet or information about that device. And if you operated it higher than that, then you would risk immediate damage, if not outright destruction of the component. I've seen this happen with plenty of LEDs. I wasn't paying attention, and the thing made a zap sound. It fried, if not outright exploded. All right, so the beginning of any circuit is going to be a power source. Circuit needs electricity to function by definition. And we can talk about a power source in a couple of different ways, as well as ideal circuits for real circuits. I've mentioned in previous videos about direct current and alternating current. You can invert direct current to provide alternating current. You can rectify alternating current to provide direct current. We do this all the time. Power supplies, those sort of bricks that you seem to have to plug into a device, wall chargers, etc. We're doing it constantly. For most of hobby electronics, we're going to be talking about direct current or using devices that rectify alternating current into direct current. Some of our typical DC sources when it comes to hobby electronics will be wall adapters. Those could be just a straight barrel jack that plugs into something, or we may have a wall adapter that we plug a USB cable into, or maybe not even a cable. Plugged in. It has to have might have to have the wall adapter might have to have a particular type of cable, so it's not something you can easily remove. Or we're just talking about a battery, or it could be we're powering something from our single board computer or development board. Unless you're going straight from literally two leads off a battery directly into like your power rail on a breadboard, the power supplies will be protected, they'll be regulated. Keep in mind, every power supply does have its limits, just like any other component. There can also be a concept of a difference between a source that maintains a steady current by varying the voltage or a steady voltage by varying the current. This is sometimes actually represented as different items in a circuit simulator as either a voltage source or a current source. All right, so we've now talked about power sources, and now we're talking about grounds. I've previously mentioned how circuits can be thought of as like a hill or a ramp. You have a ball at the top. The ball itself represents voltage, which is electrical potential between 2 points, and then the current can be sort of thought of as the rate of speed. The top of the hill itself represents our power source, and the bottom of the hill represents ground. When serious study of electricity was in the mid 18th century, they realized that electricity needed to flow through a circuit. There's an end point, there's a beginning, there's an end. Although it wasn't actually until 1870s or so that we started using the term ground to describe the end of a circuit, and even in some places that standard term is earth. Power source definitely uh, almost certainly has a positive and a negative terminal, the top of the hill, the bottom of the hill, which makes the circuit truly circular, as it were. However, keep in mind that ground has its limits, just like a power source, especially if they go to the same power source. As I mentioned the previous slide, um, if you go just flow from positive to negative, you get a short circuit, and that creates heat, often very quickly, and so it's incredibly dangerous. Now, if we had a perfect ground, especially that one that wasn't connected to the power source, it could absorb any amount of current safely, and any heat that's generated, dissipated by electricity. And in fact, actually, if you go back to Benjamin Franklin and the lightning rod, that's what the copper wire was for. Electricity flowed from the lightning strike all the way to a wire where it hit the earth, which basically is a perfect ground, or about as close to a perfect ground as we can get. Um, there may be plenty of instances actually where our ground is not necessarily attached to our initial power source as well, but we'll talk about that later. And of course, there's different types of grounds. There's earth grounds, gassy grounds, signal grounds, etc. But we're not going to think about any of that right now. Right now, we're just thinking of ground as a generic idea in our circuit. And in fact, what you should do is you think of the ground as a reference point. It defines that relationship between the top of the hill and the bottom of the hill. Don't think that that's where electricity just quietly goes off to die. The electricity you're not using components, because then you run into the problem where you may actually forget that ground itself also has its. Now we can talk about short circuits. We've already talked about them previously, where we talked about the instance of directly attaching power to ground. And of course, if those two things are both terminals on the same power source, that can cause immediate heat and damage and other problems. What a short circuit in general just means, it just means a shortening circuit. Usually that's unintentional. Um, Something has bridged pathways that weren't meant to be joined, and it could be something as simple as a loose wire, anything that's conductive. I mean, even a blob of solder is conductive, and that can cause problems. So yeah, this can result in components receiving unintentional voltage, current, above and below their ratings, which could result in damage or destruction. You probably won't have any short circuits that are too dangerous in hobby electronics. It really depends. Um, but yeah, things could still get extremely hot and burn you and whatnot. But if you have a problem, say a short circuit inside a wall outlet adapter, that could be bad. Although a lot of devices, power sources that have ways to both regulate, and they have things like circuit breakers and fuses and whatnot. You can run into the same situation feeding too much into a single board computer or development board, or whatever, which we'll get into in later videos. But those have protections, at least to a point. It really depends how much voltage, how much current. This is what I call the simplest little circuit. In fact, if you remember from what I described Ohm's law, I basically use this. Got a power source, in this case 5 volts. You'll notice plus and minus terminal there. It's got a ground, which is linked to both the negative terminal and just the circuit in general. And it's got a single component, which in this case is a resistor. Um, Now, in an ideal circuit like here simulated, That's this is fine. But keep in mind current limit flowing back into the power source in a real circuit. So this might not be sufficient enough not to cause a problem, but who knows? It really depends on the ratings. All right, and here I have something that's a little bit more practical, a simple LED circuit, really where you should begin. Now, I've made this in every circuit, which is a software-based circuit simulator that runs in a web browser. Uh, Two circuits are basically the same. They both have a 5-volt power source. They have a resistor, and then they have an LED. I mentioned how LED have ratings as well, and we wanted something around 2 volts at 15 to 20 milliamps, probably safe for LEDs. In this case, actually, the current is considerably lower. um, Only change in the examples between the two is the one on the left is 220 ohm resistor and 330 ohm resistor. Now, keep in mind the amount of light brightness you see on a circuit simulator is not representative of real life for reasons. 220 ohm resistor might be the lowest you can safely use without destroying the LED. You might be able to get it down to 100, 130, but I wouldn't go any lower than 220. And in the case, of course, if I increase the resistance, the current goes down. But to be honest, in a real life representation of the circuit, if you want to try it out, you could probably go as high as a 1,000 ohm resistor and it won't be bright nor dim. Might even be able to go higher than that. Of course, here we have the same circuit, although I've only made one and I've used a 200 ohm resistor, and this is in Falstad circuit simulator. But yeah, just keep in mind this is a simulated circuit. All right, just to recap, a circuit is a complete pathway for electrical current to flow from power source to ground. The power source needs to either be above or in some cases below the ground. Basically, you need some definition of the hill slope. If they were both the same, then there would be no flow. All components, and this includes power sources and ground, have some kind of operational ratings. Usually there's a maximum and it's suggested, and exceeding these can result in damage or destruction of components, or in the case of higher voltages current, that could be explosions, burns, electric electrocution, death. Although with hobby electronics, you're probably not risking the death part. Keep in mind that electricity dissipates as heat, and there's no way around that. um, Power source and ground. If you connect them together, that's going to make a short circuit, especially if they're both part of the same device, positive and negative terminals on a battery. And then heating up those components is bad. Um, you generally want at least one component in the middle to make a safe circuit. Like you could put in a resistor. Keep in mind throwing in any old resistor, you're still going to have all that current flowing to ground. Can the ground actually take that amount of current? You should always check ratings. Um, and then a power source, if it's two terminal, positive and negative, the positive is the power source, and the negative is the ground. Which again, this is why ratings are important. Feeding pack current to say a battery is not good. A short circuit in general is just another pathway. It's usually unintentional, or at least I hope it's unintentional, for current to flow, which that could result in damage or destruction to components, depending on voltage and current, or at the very least, here in normal operation. As you saw, I made a simple circuit with a resistor. That's usually the bare minimum for a safe circuit. But I also made some ones with a resistor and an LED so that you can actually see the effects of that circuit. You could try this in real life, but keep in mind I wouldn't use a resistor lower than about 220 ohms. You might be able to get away with 100 and 130. I don't recommend that. But you could go with as high as 1K and you're still going to see the LED lit. Well, I hope this explained all the basics to a circuit, and it might even get you started with using something like a circuit simulator to try to learn things on your own. Till next time, have a good one.